Hello, hello, hello. Yeah. We'll start. I'll start sharing the screen. Up to what point we have covered in last lecture? Voltage commutated chopper is over or not? Voltage commutated chopper completed. Hello. Up to what point we have covered in last lecture? Voltage commutated chopper. Just I will overview this. Chopper circuits based on thyristor and connections and whether it is voltage, current or load commutated. There are two types: voltage commutated, current commutated and load commutated choppers. What are their principles? Voltage commutation means application of large pulse reverse voltage, usually by switching a previously charged capacitor. This is the principle of voltage commutation, voltage commutated chopper. And in current commutation choppers, external current pulse is used and load current is applied in reverse direction. That means load current के डायरेक्ट अपोजिट डायरेक्शन में कम्यूटेशन करंट फ्लो करके that device can be turned off. And in load commutation, thyristor is turned off when load current flowing through either becomes zero due to the nature of the load circuit. If the load is consisting of RLC, then there will be a sinusoidal or damped type of waveforms will be generated, and automatically the device can be turned off because of the nature of the load current or load voltage nature AC type, and it can be turned off by transfer to another device from the conducting SCR when the current is transferred from the main SCR to the other SCR. These are the three categories of the choppers: voltage, current, and load commutation. Voltage commutation we have seen in the last lecture. A parallel capacitor is used to turn off the main SCR, and a auxiliary SCR is used to charge the capacitor. So auxiliary SCR and a capacitor is used to turn off the main thyristor. Its circuit diagram, working principle, design of the component L and C, how to find out the values of L and C, or how to design the commutation circuit for voltage commutation. Its waveforms at different time intervals by applying the gate pulses to the thyristors 1 and auxiliary thyristor. What is the current flowing through the thyristor? What is the nature of the capacitor voltage? What is the nature of the voltage across the thyristor, and what is the nature of the load voltage? What are disadvantages of voltage commutated chopper? A starting circuit is required. We need to turn on the auxiliary SCR to charge the capacitor. Initially, it is required to charge the capacitor by initially triggering the auxiliary SCR. So starting is required. That is the disadvantage of the voltage commutated chopper. It cannot work at no load because C would not get charged from minus Vs to Vs when auxiliary SCR is triggered for commutating the main SCR. These are the drawbacks of the voltage commutation. These are the designing steps. Finally, you need to remember this formula of capacitor. How to find out the value of the capacitor? It is equal to T off into I0 by Vs, where T off is the circuit turn off time. It should be the SCR turn off time, and load current or input current both are same here. You can use load current and the source voltage. And the value of the inductor can be calculated by using this formula. L is equal to or less, real L is greater than or equal to Vs square by Vs by I0 whole square into the capacitor, where Vs is the input voltage or source voltage and I0 is the load current and C is the commutating capacitor. Rishabh Gawai. These are the designing steps of the commutating components L and C, which are required for the turn off of the main SCR. So this way, the commutation circuit can be designed for voltage commutation choppers. Then current commutating chopper or current commutation chopper or current commutated chopper. Here the circuit diagram for current commutation chopper is shown in figure. It also consists of the main SCR, auxiliary SCR, and the commutation circuit consists of the components PA, CL, D1 and D2. What is PA is the auxiliary SCR, and that means T1 is the main SCR, main current carrying SCR. This SCR carries the load current. PA is the auxiliary again, which is required to turn off the main SCR. The commutating circuit consists of the components auxiliary SCR, capacitor, inductor, D1 and D2. And FD is the freewheeling diode. When the load is inductive, the stored energy in the inductor will be freewheeled through this path. It is a freewheeling diode. Where it is used, this current commutation chopper is used in Morgan's chopper. Now we have seen voltage commutated chopper. Where it is used? What is the application of voltage commutation chopper? मैंने बताया था. It is used in Jones chopper. Jones chopper circuit uses the voltage commutation, whereas the Morgan's chopper uses the current commutation. These are the applications of this voltage commutation and current commutation. Now, there are some assumptions. We have to assume the following conditions for the current commutation or current commutating chopper. What are these assumptions? Load current is constant. There is no fluctuation in the load current. Load current should be maintained constant. Ideal conditions we are assuming the load current is constant. SCR and diodes are ideal switches. That means when the switch is in the on condition, maximum current flows through the circuit. When the switch is in the off state, minimum current flows through the circuit. There are no losses ideally. That means the switches are ideal. Charging is so large that it can be treated as open circuit during the commutation interval. That means the value of the commutating capacitor is too large. That means it will act as an open circuit during the commutation interval. That means there will not be any current flowing through the chopper. So there will not be any path for the current to flow ahead of the capacitor, and the device which is next to capacitor is not carrying any current and it will turn off. During that period, the capacitor will act as open circuit. Then the merits of the current commutated chopper are: commutation is reliable as long as the load current is less than the peak commutating current ICP. That means this commutation is only reliable when the load current is less than the capacitor current. Which capacitor current? Peak capacitor current. There is some peak capacitor current, maximum current flowing through the capacitor. If it is 50 amperes, then our load should be less than 50 amperes. It should be 45 or 46, 47, not greater than that. It should be less than the peak capacitor current ICP. Capacitor is always charged with the correct polarities, and PA is naturally commutated. The auxiliary thyristor is naturally commutated as its commutating current passes through zero value in the ringing circuit formed by the L and C. What is this ringing circuit? It is a resonant type of circuit which generates the sinusoidal waveforms. Pratik Dhumali, what is this? He wants to join now. Maybe some other people also may be joining in between, where they don't require any permission from me if they are logging in from the Terna ID. Initially there were only 21 students, now there are 27. That means 6 have joined after the lecture has started. So this is happening. Okay. So To turn off the auxiliary SAR, the commutation circuit will take care of it. The commutation circuit consisting of the components L and C forms the circuit which generates sinusoidal type of waveforms, and when that waveforms appears across the auxiliary SCR, that means the current will be crossing zero value at some point when it is a sinusoidal type of waveform, and at that point when the current is passing through zero value from positive to negative, the SCR, auxiliary SCR, will be turned off, and it is a natural commutation. When the input appearing across the device is sinusoidal, that means AC type, then the device will be naturally commutated. These are some assumptions and merits of the current commutated chopper. Then how the chopper works, how the current commutated chopper works. Can you see this full screen? Can you see this full screen?
Yes, sir.
Okay. The circuit diagram and the operation of the current commutated chopper. So let us begin with the operation of the chopper circuit. Capacitor is charged to Vs through Vs, C and Rc. Capacitor is charged through Vs, that is the source voltage, capacitor, and Rc, the charging resistance. Here it is. So capacitor charges through this path. Vs, capacitor, charging resistor, that is capacitor's charging resistance, and back to the source. So this way the capacitor is charged initially. Main thyristor T1 is fired at T is equal to 0. That means in the beginning on the waveforms we can show T is equal to 0, where we apply the trigger pulse to main thyristor T1 at T is equal to 0, so that load voltage V0 is equal to Vs. When the main thyristor T1 is triggered by applying the gate pulses to it at T is equal to 0, the load gets connected to the source. Means we can get the load voltage equal to the source voltage. There is a contact between the input and the output directly connected when the मेन थायरिस्टर T1 is turned on. हर्डल कहाँ पे है? ये है. ये अगर कंडक्ट कर रहा है, that means short circuited, then this source is connected to the load. Load will get energy from the source directly if this T1 is turned on. This will be the path of flow of current Vs, T1, then load and back to the source. So we'll get the load voltage V0 is equal to Vs. V0 is equal to input voltage or source voltage. At T is equal to T1, the next time interval where we want to turn on the auxiliary SCR, the reason is to turn off the main SCR because it is conducting, and now we want to disconnect the load from the source. And what is the way to disconnect the source from the load? To open this main SCR. How to open this? Because the input is DC, the natural commutation is not possible because the current will not go to zero value unless and until it is forced to do. So we have to turn off it forcefully. What we have to do for switching off this T1 forcefully? We need to turn on this auxiliary SCR TA. At T is equal to T1, the auxiliary SCR TA is turned on to commutate the main thyristor to disconnect the source from the load, or to get zero voltage at the load. With turning on TA, an oscillatory current IC is set up in the circuit. When this auxiliary ACR is turned on, because of this inductor, this current will be flowing through L and C here. So it is forming a resonant circuit, tank circuit. Oscillatory current means sinusoidal type of current will be flowing through the circuit. It gets natural IC is set up in the circuit at to Vc is equal to Vs. That means this capacitor is fully charged. This capacitor is fully charged and IC tends to reverse the polar auxiliary thyristor TA. That means IC tends to reverse the auxiliary thyristor TA. It gets naturally commutated. Vc is equal to minus Vs at T is equal to T2. That means at T1 auxiliary ACR is turned on, it will allow the current to flow through the circuit. This path TA, L and Vs will be the path of flow of current when TA is conducting. During that period, oscillatory current is set up in the circuit. That means the capacitor current. Now next instant at T2, T is equal to T2, Vc is equal to minus Vs. The voltage polarities are reversed and IC tends to reverse because it will be fully charged and it will act as open circuit, and at T2 the capacitor voltage will be reversed and IC tends to reverse in the auxiliary thyristor. That means the current will be flowing in the opposite direction. Because a sinusoidal type of waveform is generated, means the voltage polarities are bound to be reversed. Sine wave generate होगा वहां पे L and C से. So these polarities will be reversed and minus terminal will be here and plus terminal will be here. That means the SCR is reverse bias. As TA is reverse biased and turned off at T2, auxiliary current IC begins to flow through the CL, D2 and T1. Now where from this current will flow then? CL, D2 and T1. T1 अभी तक turn off नहीं हुआ है. Remember, please remember, this is yet not turned off. इसको on भी किया, off भी किया, right? But first हमने क्या किया? At t is equal to 0, this is turned on. At t is equal to t1, this is turned on, and at t is equal to t2, this will be turned off because of this voltage polarities are reversed. Now the current, capacitor current will flow through the path. ये diode on होगा and it will flow through this path. So the capacitor will discharge through this path. So what is happening here? Please listen it carefully. There are two currents flowing through the SCR. One is the ये सोर्स के थ्रू जा रहा है वो करंट, लोड करंट ऐसे फ्लो होगा इन दिस डायरेक्शन. I0 जो भी दिखाया, that is the main current or load current which is flowing through the thyristor T1. Now because of this peak current, IC capacitor current is reversed and it is flowing through this path. Inductor D2 and thyristor T1 and back to the capacitor. This current is flowing in the opposite direction of the load current through the thyristor T1. So there are two currents flowing in the main thyristor T1. One is load current, the other is commutating current. As TA is reversed by auxiliary, IC begins to flow through the CL, D2 and T1. CL, D2 and T1, and this loop will be closed. At T is equal to T3, IC rises to I0. What does it means? At T is equal to T3, at the instant T is equal to T3, there are three time intervals now, third time interval. First is T is equal to T0, second T is equal to T1 and T is equal to T2. Now we are at T is equal to T3 at t is equal to T3, capacitor current rises to the load current. That means the two currents which are flowing through the main thyristor are equal in magnitude and opposite in direction. Right? Two currents flowing in the main thyristor. What are the two currents flowing through the thyristor? Main thyristor. One is the load current, which has started flowing through the circuit at t is equal to T0, and at t is equal to T3, the capacitor current rises to the value equal to I0, and that is the commutating current. So the two currents are equal and opposite, the resultant current will be 0. So the current flowing through the thyristor T1 is 0 at t is equal to T3, and when the current flowing through the thyristor is 0, the thyristor will turn off because the condition is satisfied. The current flowing through the thyristor is less than the holding current value. Holding current value is always greater than 0. Now here the current becomes 0, that means it is less than holding current, and this thyristor T1 will be turned off. Since the oscillating current through T1 turns it off, it is called as current commutated chopper. प्रीवियस सर्किट में जो देखा था हमने वोल्टेज कम्यूटेटेड चॉपर में, the capacitor voltage was appearing across the main thyristor, which was in the reverse. That means the anode was negative and cathode was connected to positive because of the parallel capacitor, and that capacitor voltage was responsible for turning off the main thyristor. Here the capacitor current is responsible for turning off the thyristor. That's why it is called as current commutated chopper. Oscillating current through T1 turns it off, which is called as current commutated chopper. The oscillating current means the current which is flowing because of this L and C is responsible for turning off this main thyristor T1. So at t is equal to T3, here T3 is turned off. After T3, IC supplies load current I0 and excess current. Now at t is equal to T3, IC supplies load current I0 and the excess current ID1 is equal to IC. ID1 may be current flow hoga, that will be the capacitor current. ID1 is equal to IC minus I0 is the conducted through diode D1. The difference between the load current and the capacitor current is flowing through the diode D1. After T4, a constant current equal to I0 flows through Vs, C, L, D2 and load. Vs, C, L, D2 and load. Vs, capacitor, L, D2 and load back to the source. At t is equal to T4, constant current equal to I0 flows through the path, source voltage, capacitor, inductor, diode D2 and load back to the negative terminal of the source. Capacitor is charged linearly to source voltage Now the capacitor is charged linearly to source voltage Vs at T5, the fifth time interval. Capacitor voltage after T4, the load current is flowing through the path Vs capacitor, inductor, D2, load and back to the source. In that process, the capacitor voltage is equal to Vs. That means capacitor is charged to the voltage which is applied across the capacitor, that is Vs. So during time T5 to T4, IC is equal to I0. The load current which is flowing through the circuit is same as the capacitor current during the interval T4 to T2, sorry, T4 to T5, not T5 to T4. In this commutation, an opposite current pulse will be injected through SCR. As a result, current decreases and finally comes to zero if both the current would be equal and opposite. Anti-parallel diode is useful to apply the reverse voltage after current through SCR becomes zero. The value of the reverse voltage is low. Anti-parallel, this diode, it will apply the reverse voltage across the SCR when the current flowing through the SCR is zero. That means when the commutation current and load current are equal, this diode is conducting and it will apply a reverse voltage across the thyristor, main thyristor. एंटी पैरेलल डायोड एक कनेक्ट किया है, एंटी पैरेलल मींस इसका एनोड और इसका कैथोड कनेक्ट किया है, तो एक दूसरे के अपोजिट डायरेक्शन में है, उसके लिए उनको एंटी पैरेलल बोलते हैं. पैरेलल में है लेकिन कनेक्शंस कैसा है, एक का एनोड दूसरे को कैथोड को कनेक्ट किया एंड वाइस वर्सा. दैट्स व्हाई इट इज कॉल्ड एज एंटी पैरेलल. जो एनोड इसका अगर पॉजिटिव है तो उसका कैथोड पॉजिटिव होगा. The value of the reverse voltage is low, so turn off time increases, turn off power loss increases. Current IC, IT1, IFD and I0 are treated as positive. All the currents flowing through the circuit are positive. Turn off power loss increases. That means the power during the turn off is more. Turn off is the dynamic characteristic, changing characteristic. So in that we have to maintain the minimum values of the current and voltages so that the power loss will be less. Here it is not possible, so the power loss is increased as turn off times are increased. ज़्यादा time ले रहा है turn off के लिए, that's why the power loss is increased. Voltage VC, VT1, VTI and V0 are taken as positive with polarities as marked. जो भी दिखा है यहाँ पे प्लस माइनस VTA इसके अक्रॉस, ये प्लस ये माइनस रहेगा, ये प्लस ये माइनस रहेगा, डायोड का भी ये प्लस ये माइनस, लोड वोल्टेज प्लस माइनस एंड सो ऑन. Design considerations. How to find out the values of the commutating components L and C. Designing means chopper circuit, in any commutation circuit, design is to find out the values of the inductor and capacitor which will be useful of the main thyristor. How to select the values of the capacitor and inductor so that the commutation will be proper. Turn off of the capacitor will be correct. There should not be any false turn on or turn off. That's why these values should be selected carefully. That's why the design steps are important. L and C values should be calculated for reliable commutation for this chopper. The governing conditions for the values of L and C are provided as below. The first step is peak commutating current IC peak must be more than the maximum possible load current I0. This is essential for reliable commutation of the main thyristor. The current carrying capacity of the capacitor must be more than the load current flowing through the circuit. So this is the first condition to select the capacitor. The oscillating current is the commutation circuit. The oscillating current in the commutation circuit is given by IC, the current flowing through the capacitor due to the oscillations produced in LC circuit. The current flowing through the capacitor because of the oscillations is given by source voltage into under root of C by L into sine omega 0 t. And this is equal to IC peak into sine omega 0 t. As per design requirements, IC peak is equal to Vs into under root of C by L, which should be greater than the load current I0. These are the conditions, which is given by Vs into under root C by L, which is equal to X into I0. X means some amount which is greater than the 1. We want the capacitance to be more than the load current. Some X amount must be selected, and that is given by X is equal to ICP divided by I0. X varies between 1.4 and 3. We need to fix the values of the capacitor current and load current depending on this variable X. Then circuit turn off time TC must be greater than thyristor turn off time T off. ये आपके इसमें भी आया था ना, ऑनलाइन एमसीक्यू टेस्ट जो हो गया परसों, उसमें पूछा था ये. So you have to remember this condition that the circuit turn off time must be always greater than the SCR turn off for the reliable turn off of the SCR. If the circuit turn off time is less than the SCR turn off time, it may happen that the SCR will not turn off. So the whole purpose will not be served. अगर उसको जहाँ पे टर्न ऑफ करना है वहाँ पे टर्न ऑफ नहीं हो रहा है तो पर्पज ही सॉल्व नहीं हो रहा है. You have to maintain the turn off time of the circuit. Circuit turn off time means जो भी LC components यूज कर रहे हैं उसका RC constant रहता है, that should be greater than the SCR turn off time. SCR turn off time तो उसका डेटा सेट में दिया हुआ रहता है, some 5 microseconds, 10 microseconds, depends on the type of the SCR. And we need to provide the circuit turn off time greater than the turn off time of the SCR which is mentioned in the data sheet. If the turn off time of the SCR is 5 microseconds, then you need to keep the circuit turn off time 7-8 microseconds, so that there will be proper turn off of the SCR. TC is equal to T off plus delta T. Circuit turn off time is equal to the SCR turn off time plus the small duration, that is delta T. Means TC should be greater than T off by some fraction or some time constant. W0 TC is equal to pi minus 2 theta 1 is also ICP is equal to sin theta 1 is equal to I0, theta 1 is equal to sin inverse I0 by ICP is equal to sin inverse 1 by X. Circuit turn off time of main SCR TC is equal to 1 by omega 0 pi minus 2 theta 1 by omega 0 pi minus 2 sin inverse I0 by ICP. As load current increases, T off decreases. T off is the SCR turn off time. TC is equal to pi minus 2 sin inverse I0 by ICP under root LC. Finally, this value of the capacitor is equal to under root of C is equal to TC divided by pi minus 2 sin inverse I0 by ICP into under root of L. Now, substituting the values of under root C in Vs is in Vs under root C by L is equal to xi0, we get Vs by L, this thing is equal to x into I0, and from this we can get the value of the inductor. L is equal to Vs into Tc divided by x into I0 pi minus 2 sin inverse 1 by x. Now, what are these different terms used in this equation? Vs is the source voltage, Tc is the circuit turn of time, x is the fraction of the current which is more than the load current. IC current should be greater than the load current by this fraction factor x, and x is the factor. Okay, so all these terms are known to us. We can find out the value of the inductor, and similarly by putting all these values of inductor in this equation, we can get the value of the capacitor. C is equal to x I0 Tc divided by Vs into pi minus 2 sin inverse 1 by x. These two formulas are important to find out the values of L and C for the current commutated chopper. These are the main two steps, L and C values. How to find out it? There are steps given, but they will not ask you to design it. They will ask to find out the values of the inductor and capacitor, and what will be the given thing, the circuit turn of time, the source voltage, the load current, capacitor current. From that you can find out this value of x. So you have to use the tricks steps to find out the values of the inductor and capacitor from the known formulas. IO दिया हुआ रहेगा, IC दिया होगा रहेगा, तो you can find out the x. IC peak दिया हुआ रहना चाहिए, IC peak the current, the maximum current which will be flowing through the capacitor, that should be known to find out the values of the x. You can find out the value of x from this IC peak, capacitor current, peak value, and the load current. From this you can get the factor x. और IC peak कहाँ से मिलेगा? Vs into C by L, ये सब इंटररिलेटेड है. इंडक्टर वैल्यू नोन रहेगा तो यू कैन फाइंड आउट द पीक करंट वैल्यू, या फिर ICP I0 पता रहेगा तो यू कैन फाइंड आउट द x factor. And you have to remember that the x varies between 1.4 and 3. It should not be less than 1.4 and should not be greater than 3. 3 से ज़्यादा रहेगा तो बहुत हाई करंट रहेगा, लोड करंट से 3 times ज़्यादा मतलब the capacitor will be of very large value and there will be losses etc. So maximum 3 times greater than the load current and minimum 1.4 times. I hope this is clear to all. Current commutation chopper. Circuit diagram design. The assumptions. What are ideal conditions to be assumed while studying the commutation of the chopper? Current commutation of the chopper. Then what are its merits? Operation of the circuit. How the circuit works. How the main SCR is turned off by turning on the auxiliary SCR. Why it is called as current commutated chopper? Because the current flowing through the main thyristor itself is responsible for turning it off. At a point, there will be two currents flowing through the main thyristor, but they will be in the opposite direction. And if the magnitude of these two currents become equal, the resultant current flowing through the main thyristor will be zero, and the diode which is connected in anti-parallel with the main thyristor will apply a reverse voltage across it, and as the conditions are satisfied to turn off the SCR will be turned off. What are the two conditions to be satisfied? at least one condition. The current flowing through the SCR must be below the holding current value. Second condition can be a reverse voltage must be applied across the SCR. So the two conditions are satisfied here. The current will be zero and reverse voltage is applied because of this anti-parallel diode. Therefore, it is called as current commutated chopper. Previous case में voltage commutated था. Why it was voltage commutated? That you are well aware of it. The capacitor voltage is responsible for turning off that SCR. Then the designing steps, how to design or how to find out the values of the inductor and capacitor, and you have to also remember the value of X, the range of X, it should be between 1.4 and 3. So let us conclude here for today's lecture, and we'll continue in the next lecture with the load commutated chopper. Okay. अभी भी ज्वाइन हो रहे लोग. Just I will take the attendance and we'll close here. ठीक आहे. आता आता आपण लेक्चर स्टॉप करतोय ना, तरी पण अर्धा तास लोक याच्यामध्ये असतात, आहे का नाही चमत्कार? विशाल,
हाँ सर.
आता मी लेक्चर बंद करतोय ना आणि थोड्या वेळाने चालू करतोय परत. हीच लिंक तेव्हा
ठीक.
लोक आपल्या क्लासमधले तिथं दिसतात.
हाँ
काय
सर. सर
हा
प्रॅक्टिकल्स होणार आहेत का आपले?
प्रॅक्टिकल्स म्हणजे
प्रॅक्टिकल एक्झाम वगैरे काय असेल तर?
प्रॅक्टिकल एक्झाम नाही आहे ना, याला ओरल असेल.
अच्छा, बट होणार का ते?
हा
ओरल एक्झाम कधी होणार आहे काय?
एक्झाम आता अजून त्याचं शेड्यूल येईल ना, त्याला वेळ लागेल खूप.
डिसेंबर फर्स्ट वीक पर्यंत समजेल का? का डिसेंबर फर्स्ट वीकला एक्झाम असेल आपली?
हो 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 हो, तेवढं 1 महिना तरी अजून असणार त्याला.
अच्छा अच्छा,
आफ्टर दिवाळी.
ओके ओके.
ठीक आहे. तुम्ही लोक ना, मला नाही कळत का तुम्ही असं, म्हणजे काही लोक नुसतंच जॉईन करून कुठं गायब होतात, काही रिस्पॉन्स देत नाहीये. आणि काही लोक आता लेक्चर संपलं तरी बघ तू अवेलेबल असतात तिथं, म्हणजे त्यांनी लॉग इन करून सोडून दिलेलं आहे. ते शुड नॉट हॅपन ना. आणि मी ते सगळं रेकॉर्ड करतोय, सगळ्यांचे स्क्रीनशॉट घेऊन ठेवतोय, कोण किती वेळानं लिव्ह केला क्लास. फोटो पाठवू काय काही? असं नका करू ना.
हो सर.
ठीक, चला बाय.
हां बाय सर. थँक्यू.